Thanks everybody for joining. So what we're going to do today is we're going to walk through like a presentation and sort of a bunch of development tooling and getting started tutorials to, especially for the newcomers, if you're still trying to find your way in terms of what tasks need to be done, how to go about doing those things, and sort of like a centralized place to look for all that information. I'm just going to walk through what we have and what we can use to get started and start onboarding people, new people in particular, on those tasks. And if by the end of the presentation, you feel there's something still missing or there's something that can be added, please let me know. I'm more than happy to add it to the presentation and to the site as well. And also, if you feel like I'm missing something in the presentation, feel free to interrupt and ask questions during the session. So I want to keep it interactive and it doesn't have to be one-sided like a monologue. So feel free to jump in and ask questions in the middle. But it's going to be like just an overview of the different tooling, the suggested workflow, like how we should go about organizing ourselves, finding tasks to work on, and just some good housekeeping habits with regards to those tasks. Yeah, so with that, let me share my screen. So I'm going to share like a website first where we are sort of building all of this, the umbrella that we are building all of this under. So the site is called powercommons.org. This is like where we're open sourcing and developing the new, A2O is already open source, but this is the upgrade project and everything that we are going to be developing together against the A2O Core, like the modernization and the ISA upgrades and booting and a whole bunch of other tooling. So the first thing I would highly recommend all of you to do is to go onto this site, make yourself familiar with what's on the site, the different sections, and there's a whole bunch of information there already. So I would highly recommend at least going through the getting started section, the quick start, setting up your development environments, and there's instruction for setting up a Windows subsystem for Linux using Debian or Ubuntu. There's instructions on setting up Vivado in your WS installation, setting up Litex, and the PowerPC build tool chain if you want to set up the GCC tooling for building Linux kernel for PowerPC and all of that. Some instructions on building the first bit stream and basic troubleshooting guidelines. The other thing I wanted to discuss today was I have a presentation that I'll walk through, like all of this, is if you look at the project sections, you will see like a couple of projects that we have been discussing, and it's just a more formalized listing of all those projects here. So there's some Microwatt related stuff which I've been working on, but then there is the Power Commons A2O Core project, the upgrade, the instruction set upgrade, and the modernization project. So this is where you'll see different work streams. You'll see work stream 1 through 9. And what those work streams are. Some of you have already started working on instruction set updates, and I guess there were some people also looking at VMX, VSX implementation. So this basically organizes all the different work streams in one single place. So if you have an interest and you want to understand and figure out what are the tasks that we need help with, what are the tasks that you can help with, you want to find out tasks that match your skills, or there's maybe some skills that you want to learn and understand more of, then this is the place to go. So have a look at the A2O ISA compliance workstream summary page. It's got all the different work streams and what's needed to be done against each of those work streams. So this is just a summary, then there's like details on each of those work streams listed here. I'll go into the details in just a bit, but this is the first thing I recommend everybody to do. Go to powercommons.org, familiarize yourself with the structure of the site, what's there, what are the different links. If you find anything missing, anything broken, let me know. But we're going to use this as the place to publish our work, to communicate and coordinate most of what we do in like an external facing manner. So this is all going to be public, and this is the published work stream so far. And if there's something else that needs to be added, or there's something missing, more than happy to add it here. So please add it to your bookmarks. Please go to the site and familiarize yourself. And having said that, let's move on to the actual presentation. Anybody has any questions so far on the site? Can you guys all open and visit this page?
Yeah, it works for me.
All right. Ati, Balakrishna, Karan.
Yeah. I'm like logging on like right now.
Okay. Please make sure that you can visit and you can see all the project plans and all the work item details, because that's going to be very critical once we start like distributing the workload and coordinating between different people and work streams.
Okay.
All right. I'm also going to post the link to the site in our chat for everybody, just in case. That's the site. All right, so let's get started with the actual presentation. Let me start the slideshow. Okay. Can you guys see the presentation now?
Yep.
Awesome.
Yes.
Wonderful. So what we're going to be talking through today in this session is, just the basics of getting started with the Power Commons project, how to organize and, create your development environments, how to organize your work, how to contribute, and how to see what's available for your contribution, to see what matches your skills, and a very, very high-level workflow in terms of picking something that you want to work on that you like, and then running with that ticket or with that workflow, and then all the way until like submitting your work items for review and for merging in the code base. So just an overview of the project, the agenda. So we're going to talk about what is Power Commons and what is its relationship to the A2O project, A2O Core project, Microwatt. What is Codeberg, the main development platform that we're going to be using? How does it work? Why we're using Codeberg over GitHub and all of that. An overview of our development workflow, looking at what's available, how to pick a task to work on, and how to submit the work that you've done. Getting started with basics of registration in the development platform, Codeberg, setting up your local development environment, understanding the A2O upgrade pages, what's there, what's listed there, how they're organized, how to use those pages to find or what to work on and collaborate with other people. What is the task structure on those upgrade pages, and an overview of let's say you do find a task that you're interested in, how to get from the task to the ticket and to submitting your work back to the project, the overall process, and getting help in case you get stuck. So Power Commons is sort of a broader project with the mission to democratize access to high-performance, secure, and transparent computing by creating fully open-source processor implementations. And this is like the overarching goal of the project, and the point or the path where it crosses the A2O and OpenPOWER instruction set architecture is, we basically leveraging the OpenPOWER ISA to deliver on this mission. So in case you get confused, in case you don't understand how the two connect. Power Commons is like a broader mission, and then we have basically chosen OpenPOWER ISA as one of our tools, or as one of our technologies to get to that mission. And the mission is basically to democratize access to high performance, secure, transparent computing by creating fully open source processor implementations. So with A2O, the benefit is a lot of work, most of the work has already been done. We just want to upgrade, and we just want to bring it in line with the modern tooling and modern ways of doing things. So what we're building under Power Commons umbrella for now is a revival of IBM's A2O processor core. One of the first things we want to try out is to implement the core on a modern FPGA platform. Then the next step is, I think some of you have already started working on this, ISA 3.1 modernization in line with OpenPOWER, and then eventually leading to a fully open, verifiable computing infrastructure, along with maybe Microwatt as a boot processor, and eventually leading to a full SoC. The reason or why we want to do this is, obviously for digital sovereignty, having control and visibility and transparency, not so much from a government perspective, but also a lot from a citizen perspective. We want to see, what devices we use and how they are, you just want to make sure that they are not collecting any data and they cannot be controlled remotely. We are in control of what we use and what we buy, and, be in control of the data that it generates or sends. Post-surveillance computing platforms and technological commons for all. So it should be available to everybody to experiment, to play around, and be quite open for building other open source and open devices or technologies. All right, so the philosophy out of the way, let's look at the actual technical side of things, the development platform that we use. So I don't know how many of you are familiar with Codeberg, but that's the community hosted and open source and free equivalent of GitHub. So before I go any further, I would like all of you to open Codeberg on your browsers. The site is codeberg.org. Let's do that while we are on this presentation. I'm going to share my screen and share this tab. So you'll see something like this. And I guess some of you have already joined this site, but if you go to codeberg.org/powercommons, this is where you'll see all our repositories on the platform. I'm just going to sign in quickly. One second. Let me share my screen again. Okay, signed in. So this is our Power Commons project on Codeberg. So the URL is codeberg.org/powercommons. Let me share this in the chat as well. Please bookmark this as well. We will be using this quite often. And please make sure that all of you are able to access this as well. Once you are inside the project and so Power Commons is the organization, and you'll see these different projects listed inside the organization. I'll just give you like a minute to browse the page and just see if all of you can access these repositories.
Yeah, from my end, it all looks fine. I can click through stuff. So.
Is there anybody here who can't access the repository? Okay, I assume everybody is able to access. So just familiarize yourself with all these different repos. The most important ones are the A2O and Microwatt. So A2O is basically forked off from OpenPOWER A2O, and this is where we have all the rights, and we can commit and update things as we go along. So it's just a basic fork for now. We'll start updating this as we go along. And Microwatt is the fork of Microwatt GitHub repo. We keep it synced with the upstream like every now and then, and we also commit all the changes back to the upstream one. But this is in our control, and we can change things here as we like. So just make sure you're able to see both of those. There are two other repositories that I want you to be familiar with. It's not something you will be dealing right away with, but just to know, the website powercommons.org is published with the source code for the site is under pages MD book. This contains the source for the website, and the pages repository is actually the HTML and CSS that gets rendered in the website. So in future, if anyone from you needs to make a change to the website or add something to the website, the pages MD book is the repository that you will be interacting with. So if you haven't registered so far on the site, please go to the site and you'll see, I'm logged in, but you'll see a registration link on the top right where it says register. Please register and send your username to me on the internal Slack channel, and I'll give you access as a contributor to these repositories. I think some of you already have contributor access. We have teams set up here. And we have all these people that have registered here. But if there's anybody else on the call that wants to get contributor access eventually, please let me know your username and I can add you to the repo. All right, so let's go back to our presentation. So the reason we chose Codeberg is because it's obviously, we're trying to get some funding in Europe. So it's hosted all in Europe, in Germany. The biggest differentiator for us from our vision and from our purpose, from that perspective, it's a non-profit. It's entirely community driven. So it's not backed by any corporates. There are no big corporations that hosted or supported. It's entirely maintained by non-profits and community of individuals. It's aligned with our purpose and shared values, and there are no proprietary dependencies whatsoever in Codeberg's code base. For Power Commons, I've already shared the URL for accessing the code base and the repositories. All repositories are publicly accessible. Issue tracking is integrated, wiki and merge request workflow built in. So one thing I haven't touched upon is the ticketing system or the issues and the wiki. So let's have a look at that quickly. So as an example, I'll go to the A2O repository. When you go to this repository, you'll see issues here on the top. So if you click here, you'll see this is similar to GitHub. You'll see the issue view, and if you want to create a new ticket or new issue, you can just click on new issue, and you can add the details here. You can add labels, you can add milestones or releases, and you can assign it to different people. So this is pretty similar to GitHub, and we will be using this functionality quite a bit, and I'll talk about it in a bit, how to use this and how we're going to create tickets for what we do. But just make sure that you are also able to access this page. The only other thing is the wiki, which you should also be able to access. You can create markdown files like this one already in the repository. And yeah, the wiki publishing I'll get to in just a bit. So let's get back to the presentation. All right, moving on. So especially for those of you who are new to this project and haven't worked with Codeberg or a new platform before, what we suggest on a high level, on a very high level, this would be your workflow to find out what you can work on, what are the tasks that are available, and how to go about picking those tasks and creating tickets for yourself and the work that you do, the work that you're doing. So basically, the first step is you go to the A2O upgrade pages, you identify the tasks listed there, you see what matches your interest and what matches what you want to do. You copy the task and you create a Codeberg ticket with the task saying that and assign it to yourself. So you basically say that's the task that I'm working on, and the details are all mentioned on the upgrade pages. I'll walk through the pages just now, but so this would be the first step. So go to the pages, identify different work streams, figure out what you want to work on. Each work stream has a detailed list of tasks that we need help with. Pick up a task, copy and paste the details into a ticket, and that's how we know that you are working on that task. The second step is cloning the repository. I mean, this is your local setup. I'll get into the instructions and details in just a bit. So second step is basically cloning the repository on your local machine or your local Windows subsystem Linux container. Work on the code base, push changes, and create a pull request in the repo. The step 3 is where we will review the code as a team. We'll do some testing, and we'll merge the code back into the repository. Just to reiterate, the key components or the high-level components that you'll need to keep in mind. The first one is A2O upgrade pages, where we have tasks cataloged by work stream. So let's have a look quickly. So I go to the Power Commons site, and then I go to the A2O Core upgrade page. You see different work streams here, and I don't know, let's take it as an example. I think Ati was working on the MMU part. So let's see what's in there. So here you get a summary, how many new instructions and how many instructions to be removed, and what is the main outcome expected out of the task. A lot of this is very high level. It may or may not be this could still be refined with more details. I did a very quick walkthrough and I don't know all the details of every task down to the T. So this is where we look for volunteers. We look for people like you to just help us refine and take ownership of these specific segments. So as an example, if Ati is working on the MMU part, then he can run with this, see if this makes sense with his more detailed understanding as he starts working with those tasks, and then this can be changed. High level understanding, this is what we think, and then you click on the page, and then it tells you the roadmap, how to get there. So architecture and design, I think the timelines here are somewhat high level. I mean, once you start working on those specific tasks, you will have more details and a better idea. I think Ati has been working on some of the architecture and design already. Then phase 2, phase 3, and phase 4. But this is just a high-level roadmap. If you want to get down to the task level details, then you'll see these. So you'll have an issue number or ticket number with a ticket title, and then the priority, and if it's on a critical path or not, and then some tasks with the details of what you need to go through or what things will help you to actually understand what needs to be done. So I think this is actually what you were doing, Ati, like Radik's page table walker. So some resources to help you with that, and then let's say you want to formally start with this. So create a ticket in the issues page that we saw, copy and paste this, put the issue number there, and assign it to yourself. Then we know you are working with this, and maybe eventually update this page and put your name here saying you're the one who's working with this. If there's somebody else on the team who wants to start with all the other tasks, pick up. You have all the resources and everything listed here. And this is how you basically go about picking a task for yourself. So there's quite a bunch of things. They're broken down into a bit more details here. And you can figure out. It'll give you like a good head start. But if you have more questions, if you need more details, then you can always reach out to Peter, who's here to help you. I think he would know a lot more details about probably most of these tasks. You can raise those questions in our weekly discussions, or just send us a Slack message on Slack, even if it's during the week. We work asynchronously, and I'm speaking on everybody's behalf. So we're more than happy to help you with any of the questions or queries you have with any of these tasks. So quite a detailed list, and it's the same for the other ones. So there were like a few people who have started working on the VSX implementation. I think this is a massive piece of work. I don't know how correct or right this estimation is, and the details. I haven't been able to add all the details there yet, but it should follow soon. There's one for interrupt architecture. There's details here for all the different tasks. I'm hoping to get the one for, I think, VMX implementation sometime this week. There's some stuff here, but it's not complete yet. But the other work streams are complete in that. So I want you guys to take a moment and go through some of the pages. I'll take a pause here. I just want you guys to understand and be familiar with what's listed here, and some of the other stuff like test suites and how to go about integrating and merging. That's still work in progress, but we can have like a separate session where we actually walk through, let's say, removing an instruction or adding an instruction, going through the testing and all of that, and CI/CD stuff. Some of that is still being implemented. So we can have a follow-up session on that. But for now, just focus on the work streams. Make sure you understand different work streams, what interests you, and you understand how these issues are laid out, how these things are structured, and how to pick a task and claim it for yourself when you find something interesting. So I'll take a pause for a moment. I'll give you some time to go through this. If you have any questions, feel free to ask, feel free to raise, but take a moment and think about what's there.
Yeah, I think this is super helpful, Sankar. I think one remark I'd have is, if you start working on something, even if you don't yet have all the details or you're ready to put your results in there, I think it's very important to add your name here, right, to the right task, because that's the first thing that we need in coordinating is knowing, who is doing what.
Yeah, that's a very good point. And I think what I will also do is in the workstream table that we have here, maybe add a column for the people who are, at least I know, are working on those work streams. And if there's others who feel like they want to join that work stream, they can put their names down there as well. And like Peter said, it's going to help us tremendously in terms of organizing and allocating and keeping track of who's working on what.
Yeah. All right. I think this super helpful. Don't know if there's questions from anybody.
Is everybody clear on the organization and how these tasks are organized, how to find tasks, and how to claim it for yourself?
Yeah.
Nice. Ati? Okay, Ati, you have a question?
He says everything checks out. I don't know what does it mean.
Sorry, what's that going to say?
No, I think there is a message from him saying everything checks out.
Oh, okay, nice. Oh yeah, I just saw it now. Nice. Oh, okay, his mic doesn't work. Okay.
Replace the mic, Ati. Okay.
Okay, wonderful.
Yeah, this is good. Thanks, Sanket. I think we can also socialize this to a lot of people in our network. Let us see.
Yeah.
I think this is a good platform here. It's a good start.
Thanks, Ganesan. There's a bit more I want to cover quickly, and then we can wrap this up. So Ati, you have a question. Did you include the part where we can rebuild the Microwatt project? Yes, I was going to get to that. That's exactly what I want to talk about. So let's carry on to that section. So let's continue. So this is basically what we discussed, the key components and how things are organized. So we've already gone through this one, registration and getting access to the repo. Then let's carry on. So this is basically just some instructions to set up the Codeberg Git repository on your local machine with your username and your SSH keys to Codeberg. You can follow these instructions and set up your SSH key, so you don't have to type in your password every time you clone something or if you push something. I'm not going to go into a lot of these details. It's like pretty straightforward. So this is what I also wanted to talk about. Ati, I think this talks exactly to what you were mentioning. Now, Windows and WSL setup instructions, how to set up Vivado in WSL, and building all of that. So let me go back to the page. Let's go here. So on this site, you will see getting started section, and under development environment, it tells you like what you need. So Windows Subsystem for Linux, Vivado, Litex, Fuse SSC, PowerPC toolchain. It tells you the exact installation order, starting with Windows Subsystem for Linux, and then it basically culminates with the first bitstream build that you wanted. So let's start with the Debian setup on Windows Subsystem for Linux. So this has all the instructions on getting Windows Subsystem for Linux up and running, setting up your USB device pass-through. If you have a board attached to your Windows machine, how do you basically get the pass-through working? So you need to access the USB ports for your JTAG and other interfaces in WSL, but they're attached to the Windows host. So this will basically get you through like the pass-through setup going. And we can have a specific section dedicated to this as well, but the instruction here in my mind should be sufficient. Attaching the FPGA device to your Windows and eventually in WSL, verifying that it's listed in WSL, and then setting up Vivado in WSL, and a few tips on performance and all of that. I haven't tested this for all possible combination of Windows and Ubuntu and Debian and OpenSUSE and like all those things. I'll add a few more instructions. Let's say, I think one thing I will definitely add here is running multiple environments. So in my local workstation, for example, I have 3 Windows Subsystem for Linux instances running. So one is for A2O, one is for Microwatt, and one is for, let's say, Litex with Microwatt and other things that I want to play with. You can run all of them in multiple in parallel, so your work is isolated and it's clean and it's contained. You don't pollute. The build setup for, let's say, A2O with the build setup for Microwatt, you can keep them nice and clean and organized. This is the first step. This will give you one of those with Vivado running in WSL. There's instructions setting up Vivado as well inside the WSL that you installed. And have a look at it. If you find any issues or something, let me know. More than happy to assist with that. I've tested, like I said, I've tested in my machine. not possibly with all the combinations and different versions of everything. So there could be some issues you run into, but this should work for the most part. LiteX setup instructions and PowerPC toolchain setup for compiling Linux kernel and preparing the images for cross compilation. So these set of instructions should get you pretty much up and running. If you need more help, there is a resources section. I haven't done that yet, but I will add pre-built images for the two boards that I'm familiar with, for the VCU 118 that I have, and for RTA7. I'll add those images here. And then there's also a whole bunch of resources if you want to learn more about the architecture. So I've linked Peter's repository and Peter's talks on Microwatt on RTA7 here. There's a whole bunch of other resources. There's the original or the upstream Microwatt repository maintained by Anton. Peter's work here as well, some presentations and videos as well. So we can go through all of those. I'll try and I've linked to the PDFs as well for the ISA, but I think I'll copy them and I'll add them to our repos as well. So have a look at it. There's a whole bunch of resources here. And yeah, Ati, to your question, I think these steps basically should be enough to get your builds going and get to the point to build Microwatt in WSL on Windows. If you find something missing, drop me a message on Slack. More than happy to fix and add those instructions onto the page and update the wiki as well. Any other questions so far?
Great to have it all in one place.
All right, then let's wrap up the presentation. So we talked about all the setup and getting started instructions. I think we've already talked about the work streams and the different pages, how to use them. Yeah, the structure of the task, I think I did talk about it briefly. You see a task ID against each of those, the work stream, title, description. When you decide to work on one of those tickets, this is the workflow we discussed, browse through the pages, check if the task is available, if it's not already created or claimed in the issue list. If it's not, then create a ticket for it and assign it to yourself and say you are working on that one. And how to get help if you're stuck. I guess we've already discussed this. And that's the end of my session.